Hello everyone. Last day we had done with the products of electrolysis under different conditions, and in that we had seen that the products are different if we vary the condition. Vary the condition means if the solution is molten, it is not necessary the product will be same as that in the aqueous solution phase. It does depend on one factor. I told electrode potential, but we didn't say anything about the electrode potential. So today we are going to start with that particular term, that is electrode potential. Electrode potential. Okay, that's the first thing we are going to understand today. Electrode potential. Now, what is electrode potential? Okay, we'll understand that slowly. First, you understand it. Now, suppose if we take some solution of an electrolyte containing the metal ion, whatever solution, suppose copper solution, iron solution, silver solution, whatever, zinc solution. In general, I am writing it that particular solution contains a metal ion Mn+. So whatever is M, it can be Na+, it can be Al3+, it can be Cu2+, or whatever it is. Okay. And the same metal is dipped in it. The same metal strip is dipped in it. The metal strip is dipped in it. Okay? What may happen? What are the possibilities? There are three possibilities. First, nothing will happen. No change will take place. Absolutely no change will take place. The metal will dip, metal solution will be there. There will be no change in the metal solution. There will be no change in the metal. Absolutely everything will be as it is. Second, this metal atoms, the metal atoms that is present in the strip will lose n electrons. It will lose the electrons here. It will lose the electrons here, and will convert into Mn plus. And will convert into Mn plus and will come to the solution. Okay. So some Mn plus is coming to the solution. Now please try to understand this. First of all, what is happening over here? It's oxidation that is taking place. If oxidation that is taking place, then this will behave as an anode. This is going to behave as an anode, which has got some electrode potential. Obviously this is an electrode and it has got some electrode potential. What is that? Please understand. Before dipping this metal strip, before the reaction took place, the solution that we had taken had equal amount of positive charge as well as negative charge, whatever negative charge is there. Suppose we had taken copper chloride, so whatever copper ions are there, whatever was the charge of the copper ion, same was that for the chloride ion. Okay. Copper ion and chloride ion were same. Okay, fine. Now what happens? This metal atoms, as I dipped it, this metal atoms lost the electron. So this is becoming negatively charged. This strip is becoming negatively charged because the electrons are deposited over here, and some solution, in the solution Mn plus is coming out. Okay, Mn plus is coming out. So the amount of positive charge in the solution is increasing. Amount of positive charge in the solution is increasing. The solution is becoming what? The solution is becoming positively charged. So a charge separation is generated between the solution and the strip. A charge separation is generated between the solution and the strip because of this oxidation reaction. Okay. This charge separation is responsible for the generation of some potential difference. And this potential difference is called the electrode potential, or better to say, this potential difference is called the oxidation electrode potential. Oxidation electrode potential, because in this particular case the oxidation is taking place. That's the second possibility. The third possibility is something like this. The third possibility, if I dip some M in Mn positive, the third possibility is it will accept this Mn positive present in the solution will accept the electron from here, from the metal. If it accepts the electron from the metal, these are becoming Mn positive. This particular strip is becoming positively charged because it is losing the electron. Okay, and Mn positive, the Mn positive present in the solution is accepting the electrons, to become M. So the M is deposited over here. But what is happening to the solution? Earlier the solution was neutral. Now some of the Mn positive ions are neutralized. So the charge, what charge is getting more? The negative charge is getting more in the solution. And the potential difference that will be generated over here because of the charge difference, and that potential difference is called electrode potential again. But this is happening for which reaction? This is happening for the reduction reaction, and hence we also call it reduction electrode potential, which is certainly happening at where? It is very certainly happening at cathode. But these reactions are taking place only when these two are connected, right? Only when these two are connected, because there is a redox reaction that is taking place. That is what is electrode potential. So what is electrode potential? Let me tell it in very simple way. When a metal strip is dipped in a solution containing the same metal ion, it may undergo two types of reaction or nothing, we are not bothered. It may undergo two types of reaction, one is oxidation, one is reduction. Now because of either oxidation or reduction, there is a charge difference generated between the metal strip and the solution, and this charge difference is responsible for the potential difference generation. This potential difference that is generated between the solution and the electrode and the metal strip, I should say, is called the electrode potential. If it is generated due to oxidation, then we call it oxidation electrode potential. If it is generated due to reduction, it is called reduction electrode potential. Okay. If it is generated due to oxidation, suppose this one, we denote it like this: E of M/Mn positive, means oxidation is happening over here. Electrode potential because of oxidation, and if it happens because of this, then we write it E Mn+M. Okay. Now one very important thing I am saying. This value, suppose equal to 5, if this value, the electrode potential, is found to be 5, for the same electrode, the reduction electrode potential will be found equal to -5. Means the value of oxidation electrode potential and reduction electrode potential of a particular electrode is exactly same with the opposite sign. The values are same, but the signs are opposite. Okay. And in our time, there was a huge lot of difficulties that whether oxidation is taking place or reduction is taking place. If oxidation takes place, then we had to take the oxidation electrode potential. If reduction takes place, then we had to take the reduction electrode potential. But IUPAC had changed the concept, changed the convention, and now, very important sentence I am saying, that in a particular electrode, whether oxidation is taking place or reduction is taking place, doesn't matter whether oxidation is taking place or reduction is taking place. It might, any one of this might take place. But if I ask you what is the electrode potential of it, what is the electrode potential of that electrode, we are always going to mention the reduction electrode potential. That is by convention. We are always going to mention the reduction electrode potential. That means if I ask you what is the electrode potential of this, we are always going to say the electrode potential of this is -5, not this. If you are asked that what is the oxidation electrode potential, then specifically you will say this as 5, but not otherwise. Any electrode potential that is taking that is denoted is just the reduction electrode potential. Doesn't matter in that particular electrode oxidation is taking place or reduction is taking place when used in a cell. Is it clear? Is it all about the electrode potential? That's all about the electrode potential. I hope you understood this, the basic thing. Now, electrode potentials are listed in a series, or better I must say it, that electrode potentials are listed in a series or in a table at standard condition, and that particular table is known as electrochemical series, where the electrode potential of all the electrodes are listed, electrode at the standard condition. Now what is standard condition? Standard condition, there are three things to be mentioned. One, the temperature should be 25 degrees Celsius, that is 298 Kelvin. The pressure should be 1 atmospheric pressure. The pressure should be 1 atmospheric pressure, and the concentration of the solution, concentration of the electrolytic solution should be 1 molar. The concentration of the electrolytic solution should be 1 molar. At this condition, if we can measure the electrode potential, of an electrode, then that electrode potential is called standard electrode potential and is denoted by E naught. Obviously, whenever we are talking of electrode potential, we are talking of reduction electrode potential, so we are going to write it like this in general. E naught Mn plus M should be equal to whatever value. It has got certain value, and that values are listed in a table. You don't have to remember a single value. This values required will be given to you. Clear? Fine. Now the question is that, fine, that is standard electrode potential, it is represented as this, and we consider the reduction electrode potential as the electrode potential, and when it is measured at standard condition, we get it. Absolutely fine. Okay, but the problem is that how can we measure the electrode potential? How we can measure the electrode potential? The electrode potentials of an electrode cannot be measured as such. The electrode potential of an electrode cannot be measured as such. We cannot measure. An electrode is given to you and we cannot measure the electrode potential. What can we measure is EMF of a cell. EMF means electromotive force of a cell, or in other words, in a simpler word, we call it potential difference of a cell. Now whenever I am talking of cell, it consists of two electrodes, one anode and one cathode, right? When they are connected through wire and a voltmeter, there will be a deflection, right? And this deflection is going to show us that what is the potential difference in that cell, in that whole cell. That potential difference we can measure. We can measure this potential difference. That is what is known as what? That is what is known as EMF of the cell. Okay? Now, EMF of the cell, I am writing it at what? E cell. We write it like this, E cell. Okay? Is equal to electrode potential of cathode minus electrode potential of anode. Electromotive force of a cell is nothing but electrode potential of cathode minus electrode potential of anode. Now, if we know E cell by experiment, we can measure it very easily. And if we know any one of them, suppose we know this, so we can very easily find out this. Yes, if we know any one of them, we know E anode or E cathode, the other one we can very easily find out. Okay, that is how the electrode potentials are measured, but they are measured at standard condition to get that series. Okay, standard condition means, again I am maintaining the standard condition. What are the standard condition? 25 degrees Celsius, 1 atmospheric pressure, and the concentration of the solution is 1 bar. Now, 1 molar. Now, to get the value of EMF of the cell at standard condition, we consider, okay, one electrode as the standard. one electrode as the standard electrode, and that is most importantly, most usually that is taken, the standard one that is taken is She. She means standard hydrogen electrode. Standard hydrogen electrode, which is a standard electrode. By using this particular electrode, we can measure the electrode potential of the other electrode at the standard condition. How? But before going to how, first we must understand what is She. Means what is standard hydrogen electrode? What is its construction? Standard hydrogen electrode. Say it's very simple again. What we do? We take some HCl solution where the H positive ion is obviously there, standard hydrogen I told, and the concentration of that is 1 molar. That's first standard condition. Clear? Okay. Next, we just dip a platinum wire here, just a platinum wire, a perforated platinum wire. Why platinum wire? Because it is not taking part in the reaction, it is an inert electrode. It is just used to make it connected with the other electrode. Just to make it connected with the other electrode. But that's all. Then that is actually kept, this platinum electrode is actually kept in an inverted U-tube. In an inverted U-tube like this. Okay, inverted U-tube only like this. And through this particular portion, what is passed is hydrogen gas at 1 atmosphere. At 1 atmosphere is constantly flown. Okay, 1 atmosphere. That means the standard condition is maintained and the whole system is kept at obviously 25 degrees Celsius or 298 Kelvin. So this hydrogen gas is coming in this solution. Clear? So what is there in She to be undergone reaction? Please understand it. There is H2 and there is H positive. These are the two factors of which are present because platinum is not going to take part in any reaction. Fine. Now this is connected with other electrode, any electrode. Suppose this is connected with copper. This is connected with copper. Okay, copper through a voltmeter. Through a voltmeter, we have the copper electrode and it is connected. So what we will see is the deflection over here. We will see the deflection over here. Okay, that is the EMF of the cell. Copper electrode is also kept at the standard condition. Okay, that means 25 degrees Celsius, 1 molar concentration and 1 atmospheric pressure. We will see a deflection over here. This deflection suppose is found to be, just suppose it's found to be, once again I am saying that you don't have to know the values, 0.34 volt. Okay. Now E0 cell, that is electrode potential, EMF of the cell at standard condition. EMF of the cell at standard condition should be electrode potential of cathode at the standard condition minus electrode potential of anode at the standard condition. Now this value is given to you. This value is given to you and this value is nothing but, given to you means we got it, suppose we got it as 0.34. Now in this connection, the hydrogen electrode is acting as anode. You will slowly understand that why and all. And copper is acting as cathode. Okay. So E0 cathode we have to find out. And the standard hydrogen's electrode potential is considered as 0. E0 for She equal to 0. It is considered as 0. By considering this as 0, can we find out the electrode potential of the other? So that is equal to E0 for Cu2 plus Cu. Okay, that is electrode potential for copper minus 0. Yes, minus 0 because anode is a She and it is 0. So we can find out that E0 copper equal to 0.34. So we can get it. We can get the E0 value like that for any electrode. Now once again I am saying that it is not necessary that She is always going to behave as anode. or copper is always going to behave as cathode. It's not like that. Okay, it depends on which other electrode it is connected. Suppose this she is connected with zinc. She is connected with zinc. Then she will behave as cathode and the zinc will behave as anode. Okay, it depends. Slowly, as I told, slowly we will learn why that is, and all these things we'll learn slowly. But you should know that any electrode is not a anode always or not a cathode always. It does depend that whether it is acting as anode or cathode. It does depend on what? It does depend on which other electrode it is connected with to produce or to form or to make, to what should I say, construct the cell. To construct the cell. Is it clear? Okay. So what is she, you understood? Now if I ask you, just two reactions we are going to do. This is connected with copper. What are the reaction that is taking place? What are the reaction that is taking place at anode, at cathode, and what is the overall reaction? Let us just see it. At anode, at this condition, at anode may, what happens? Oxidation happens. And what is there at anode? H2 and H positive. Out of H2 and H positive, which will undergo the oxidation, means which will lose the electron. Obviously H2 will have the tendency to lose the electron. So at anode the reaction that will be taking place is H2 minus 2E is going to produce 2H positive. That is the reaction that is taking place at anode. And what is the reaction that is taking place at cathode? Since it is copper and cathode means reduction is taking place, so obviously Cu2 positive ion will accept 2 electron and will become Cu. So what is the overall reaction? The overall reaction is H2 plus Cu2 plus producing 2H positive plus Cu. And how to represent the cell? Tell me how to represent the cell. H2 slash H2H positive, okay, double slash Cu2 positive slash Cu. This is what? This is the representation of she, but she has got a special feature to represent also, since the metal that is used for converting or flow of the current is platinum. We mention the platinum at the corner. So this is she when it is behaving as what? When it is behaving as an anode. Clear? When it is behaving as an anode. Okay. Now what is she when it is behaving as cathode? Suppose this is now connected with zinc. This is now connected with zinc. So zinc, as I told, is behaving as anode. She is behaving as cathode. So what is the reaction now that is taking place at anode? What is the reaction that is taking place at anode? At anode, the reaction that is taking place is oxidation. So zinc is losing 2 electrons and is becoming zinc 2 plus. And at cathode, the reduction is taking place. So obviously just the opposite reaction of the previous one. 2H positive will accept the 2 electron will become H2. So you can write down the overall reaction. What is the overall reaction? Zn plus 2H positive is going to produce Zn2 plus H positive. Okay, sorry, plus H2. And if I represent the cell, how it will look like? First anode. So Zn slash Zn2 plus double slash, what can I write? H positive or 2H positive slash H2. But again at the end we have to write what? We have to write platinum. This is the representation of she when it is behaving as cathode. And this is the representation of she when it is behaving as anode. Okay, hope you understood that how can we find out the standard electrode potential of any electrode by taking she as the standard electrode. Standard hydrogen electrode is as the standard one whose electrode potential is considered as 0. That is one concept. The second concept, once again I am telling that it is not necessary a particular electrode is going to behave as a particular electrode, that is anode or cathode. It might be anode, it might be cathode, depending on what? Depending on which other electrode it is connected with. Clear? And one more important thing I told today, that is the electrode potential of a particular electrode is considered as its reduction electrode potential always, doesn't matter whether the oxidation is taking place or reduction is taking place. If you see the electrochemical series where the electrode potential of all the electrodes are given at the standard condition, the values that is given are from least to the highest, where the reactions that is written, please look at your book, look at the table of electrochemical series. You will see that all the reactions that is given over there are reduction reaction, because again I am saying a very important thing, doesn't matter whether in the cell, whether at the electrode the oxidation is taking place or the reduction is taking place, doesn't matter at all. We are going to take the value of the electrode potential as the reduction electrode potential by convention. But what is the relationship between reduction electrode potential and oxidation electrode potential? The reduction electrode potential and oxidation electrode potential is nothing but having the same values but with opposite sign. If someone has got, suppose copper, I told that the reduction electrode potential is plus 0.34 volt. So oxidation electrode potential for copper will be minus 0.34 volt. Hope the electrode potential concept is clear to you, and how to measure the electrode potential, that also you understood. The She you understood, standard electrode potential you understood, standard EMF of the cell you understood, and obviously the standard condition. Now our next target will be to find out the E cell. We had found out E0 cell. E0 cell equal to E0 cathode minus E0 anode. That is, E0 cell means the cell at standard condition, at that particular condition you can get it E0 cathode, E cathode at standard condition minus E anode at standard condition. Okay, but it is not necessary that the cell will be always at standard condition. In that particular case, how can we find out? Obviously in that particular case, these values so we are going to get for the electrochemical series. In that particular case it will be E cathode minus E anode. But how can we find out the value of the electrode potential of cathode or electrode potential of anode or EMF of the cell at non-standard condition will be our look after in the next class. Okay, hope you understood that. Till then, goodbye, stay safe, stay healthy.